Hello there, Mr. Sutton here, bringing you the AB Calculus 410 Extra Practice Number 1 solutions on derivatives of inverses. On this problem, given this function and input-output pair here, I want the derivative of the inverse of the function at 3. All right, so let's start by writing our inverse formula, at least applied to this. So if I'm doing f prime inverse of 3, that's really going to be 1 over f prime of f inverse of 3. And now at this point, f inverse of 3, well, that's just the thing I have to plug into f to get 3. Looking up here, I had to plug in 17 over 10. So down here, I'm really doing f prime of 17 over 10. And at this point, we need to figure out what f prime actually looks like so we can use it. Well, in general, we can write that f is 10x plus 10, the whole thing to the 1/3 power. And now to take the derivative of that, we're just using the power rule with the chain rule. So that's going to be 1/3 times all of this stuff to the negative 2/3 times the derivative of the inner function. So that's times 10. And now if I plug in, let's see, I have to plug in 17 over 10 for this. So that's going to be, let's see here, I can put this 10 out in front. So 10/3 parentheses 10 times 17 over 10 plus 10, a lot of 10s, to the negative 2/3. These 10s are going to cancel in here. So this is really 17 plus 10, which is 27. And just rewriting all of this, I've basically got 10 over 3 times the cube root of 27 squared. Just putting that in fractional radical form. And doing a little PEMDAS here, cube root of 27, that's going to be 3. Squared is going to be 9, times 3 is 27. So this is just 10 over 27. But wait, we have to go back here now. We just found f prime of 17 over 10. So this is really going to be now 1 over 10 over 27. But we're not quite done. Let's multiply by the reciprocal to get 27 over 10. To find the derivative of the inverse at 18 for this function and function value, I'm going to start by using my inverse formula. So f inverse prime of 18, that is going to be 1 over f prime of f inverse of 18. So f inverse of 18, that's just the thing I have to plug into f to get 18, which is 1. So this is really 1 over f prime of 1. And now I have to figure out what f prime of 1 is. So let's start with f prime. That's going to be, using my power rule here, 21x to the 6th plus 10. And then if I plug 1 into all of that, that's going to be 21 plus 10, which is 31. All right, so I've really got 1 over 31 when the dust settles on this one. For this one, I want f inverse prime of 2. So I'm going to use my inverse derivative setup for this. I'm going to say this is going to be equal to 1 over f prime of f inverse of 2, like so. And let's see here, f inverse of 2, that's what I have to plug into f to get 2. Taking a look at this function value they gave me up here, I had to plug in 3 over 10. So that is what f inverse of 2 is 3 over 10. So we're doing 1 over f prime of 3 over 10. And now we need to say a little bit more about f prime. So let's say a little bit more about f. F right here, before I take the derivative, let me just rewrite this as 10x plus 5, all of that raised to the 1/3 power. That'll make it a little bit easier to use my power rule on this one. And now taking the derivative, that's going to be 1/3 times all of this stuff to the negative 2/3 times the derivative of the inner function, so times 10. And now let me plug 3/10 into all of this, and I can just rewrite this as 10 over 3 out in front. So I've got 10 over 3, and then I've got this 3/10 plugged in here. And let's see here, these 10s are going to cancel. So this is really 3 plus 5, which is 8. And I can rewrite this whole thing now as 10 over 3 times the cube root of 8 squared. Just rewriting it in radical form. So in here I've got cube root of 8, which is 2. 2 squared is 4. 4 times 3 is 12. So we've got 10 over 12, which I can reduce to 5 over 6. So a whole bunch of steps I didn't show here. But now we have to actually plug this back in for f prime of 3/10, because that's what we just found. We didn't get the answer yet. So my answer is going to be 1 over this value right here, which we can rewrite as 6 over 5. Given this polynomial and this f of 0 equaling negative 9, I want to find the derivative of the inverse of this function at negative 9. So for this, I'm going to use my inverse setup. I'm going to write f inverse prime of negative 9 equals 1 over f prime of f inverse of negative 9. And f inverse of negative 9, that's just the input that gave me an output of negative 9. So looking back up here, I had to plug 0 into the original function to get negative 9. So f inverse of negative 9 then is going to be 0. So really, I've got f prime of 0 down in that denominator. Now let me actually say a little bit more about f prime. So I'm going to need to take that derivative at this point. Using the power rule, we've got 24x squared plus 9. And then f prime of 0 is just going to be, well, this first term zeroes out, so that's just 9. So then I can just replace this f prime of 0 with 9 and come up with my final answer of 1 over 9. For this problem, I've got this polynomial, and I'm told that f of 1 is 3. Based off this, I want the derivative of f inverse at 3. So let me use my inverse setup. This is going to be 1 over f prime of f inverse of 3. F inverse of 3 is the input that gives me an output of 3. So I see that I have an output of 3 when I plug 1 into the f function. Therefore, f inverse of 3 is 1. So we can write f prime of 1 down in that denominator. And now what's f prime of 1? Well, f prime in general is going to be 21x squared. So then f prime of 1 is just going to be 21. All right, so this is then just going to be 1 over 21. Problem done. For this one, given this line and f of 2/3 equals 3, I want to figure out f inverse prime of 3. Okay, so let's check this out now. So I'm going to set this up as 1 over f prime of f inverse of 3. And f inverse of 3, that's just the thing I have to plug into f to get back 3. That looks to be 2/3, so this is really f prime of 2/3 down there. And what is f prime? Well, here's the f function. The derivative of this is just negative 6, and it's a constant negative 6, so f prime of 2/3 and everything else is going to be negative 6. So then my answer, just replacing that up here, is going to be negative 1 over 6. On this problem, I'm given a table of values for f and its derivative, and they're telling us g is the inverse of f. We want to know which of the following is the equation of the line tangent to the graph of g at the point x equals 2. All right, so I basically need to find g prime of 2 and then use that to create one of these tangent lines. So since I'm dealing with an inverse here, g prime of 2 is going to be 1 over f prime of g of 2. So 1 over the derivative of the original function of the inverse function with the number plugged in here. So what is g of 2? Well, that's the number I have to plug into f to get back 2. So looking at my table, I'm basically looking in the f of x row here. This is the output row for the f function. So to get an output of 2, I had to plug 3 in as the input. So that means now that g of 2 is going to be 3. So I really have a 1 over f prime of 3. And what is f prime of 3? Well, f prime of 3, that's right out of the table here. That's going to be 5. So this is 1/5. Okay, so that's going to be the slope of our tangent line. And we see here, looking at the answer choices, there is only one answer with a slope of 1/5, and that's choice C. But let's just keep going here. So I'm going to use point slope to get there. Y minus y1 equals m times x minus x1. And these look to be kind of point slopey in form anyway. So here's where we have to be a little bit careful, mixing up x and y values. Now the x value in this tangent line equation is the input to the inverse function. It's this 2 here. So that means that the output is what you get back when you do g of 2, which is 3. So here, this is going to be y minus 3. And then we have a slope of 1/5, and we have x minus the input to the inverse function, which is actually the output for the original function. So x minus 2. That's not quite any of these, but if you add 3 to the other side here, you will be able to match with answer choice C. On this problem, I have the graph of a decreasing differentiable function f shown above, and we also have a tangent line at the point 4, 6. Maybe that'll be useful. G now, G is the inverse of f. We want to know which statement about G prime is true. So this is basically a G prime derivative of the inverse kind of problem. In general, since these two functions are inverses, we can say that G prime of x, or whatever, is going to be 1 over f prime of g of x. So this is just our general inverse derivative setup. But now, what kind of number does g take as an input? Well, g is an inverse function, so it's going to take the outputs from the f function, which is to say it's going to take y values. So if you want to find g prime of something here, you would most likely do g prime of 6, because that's the output from the f function. So g prime of 6, then, we can write as 1 over f prime of g of 6. And let's keep going here, because this doesn't match anything yet. What is g of 6? Well, that's what I have to plug into the f function to get 6. Well, I have the point 4, 6, so I must have plugged in 4 to get back 6. So we're going to get 4 for g of 6 here. So this is f prime of 4. And now what is f prime of 4? Well, for that we can look at the graph. So here is the point at x equals 4. And the slope there is represented by this tangent line that just conveniently happens to be drawn there. This tangent line has a slope of, let's see, we're going down 3 over 4. So negative 3/4. So this is really going to be 1 over negative 3/4. But we're not quite there. We have to multiply by the reciprocal. So this is really going to be negative 4 over 3. And here's where you have to be even more careful. If you look at the answer choices, there are 2 answers that have negative 4/3. And the others are this upside down. So a lot of tricky answer choices here. Now the difference between the 2 negative 4/3 ones is the input. So notice that we have to have an input of 6, and then the derivative gives us back negative 4/3. So that's choice C, not choice A. Choice A has the wrong number getting plugged into G prime. So choice C. For this free response problem, we're given the following curve here to work with, but only for y greater than 0. First task is to show that the derivative of this is negative y over x plus y. So on a function like this, or actually I should say a curve, we don't know that it's a function yet, y is pretty difficult to isolate, impossible really, so we're going to use implicit differentiation to get dy over dx. So basically take the derivative of everything as normal, and whenever we take the derivative of something with a y, we have to multiply by the derivative of y, dy over dx, using the chain rule, because y is representing an inner function of x. So going from left to right, this 2x plus, times y, this is already going to require the product rule. So let me set up a box and ribbon for that. We've got 2x and y, and the derivatives of those are 2. And this would normally be a 1, but it's an inner function of x. So this is going to be dy over dx. Now using the ribbon to multiply this out, we've got 2y plus 2x dy over dx. And now we keep going. Derivative of y squared is going to be 2y times the tail of dy over dx. And then this is going to equal the derivative of 8, which is just 0, because 8's a constant. Now we have to get the stuff with dy over dx on one side and everything else on the other. So this 2x dy over dx can stay on the left, as can the 2y dy over dx. This 2y over here, though, we have to subtract that to the other side. And the reason we did that is because we can now factor out a dy over dx on the left side, leaving us with 2x plus 2y inside the parentheses. And now if I divide everything by this parentheses, I've got dy over dx isolated, which is great, but it does not quite match what they have up here in the problem. So to get that, we just have to reduce everything by 2, which will give us negative y over x plus y. On this problem part, they want the equation of the tangent line to the curve at the point 1, 2. So I'm going to use point slope to write this equation. I've already got a point. I still need the slope, though. Fortunately, I know the derivative of this thing. They actually handed it to me in part A. Here it is again, negative y over x plus y. So to find the derivative, I just need to plug in 1, 2 to this equation here, this formula. So doing that, that's going to be negative 2, because it's a y value up there, over, we have the x value 1 plus the y value 2. So this is a slope of negative 2/3. Plugging this into point slope, I'm going to have y minus the y value 2 equals my slope that I just found of negative 2/3 times x minus the x value 1. And they didn't say we had to put it in specific form, so we'll just leave it like this and call it done. For this part of the problem, they want us to find the second derivative for this curve at the point 1, 2. So a few key facts I'm going to recall from past parts of this problem. In part A, we saw that dy over dx was, again, negative y over x plus y. And in part B, we found that dy over dx evaluated at the point 1, 2 had a value of negative 2/3. So we already found this or knew it already. All right, let's go ahead now and find the second derivative. So let me get the general formula first. And for that, I am going to need the quotient rule. So let me set up my box and ribbon. And we're following the general format u prime v minus uv prime over v squared when we plug things in. So box and ribbon time. I've got my numerator of negative y, and x plus y is my denominator. Derivative, now be careful, we're still differentiating implicitly. Y is still an inner function of x. So anytime we take the derivative of y, we still need to multiply by a dy over dx. So this is going to be negative 1 dy over dx. And here we're going to have 1 plus dy over dx. Now, before I multiply all this out and put it back into my quotient rule, I'm actually going to plug everything in inside the box here, and then I'll put it back together outside. So at an x value of 1, a y value of 2, and I didn't mention it here, but a dy over dx value of negative 2/3, here's what we have inside our box. So negative y, that's going to be negative 2. X plus y, that's really 1 plus 2, which is 3. Negative dy over dx, well, that's negative 2/3, so positive 2/3. And 1 plus dy over dx, that's 1 minus 2/3, which is 1/3. Using the ribbon to multiply all this back out now, and this is d squared y over dx squared evaluated at 1, 2. Big fraction here. So here's u prime v. We're going to have 2/3 times 3. And then we've got minus negative 2 times 1/3. All over v squared, so that's all over 3 squared. At this point, you've got all constants, so you could actually just stop here and be done with the problem and get the credit. If you want to simplify, though, in the numerator, we've really got 6/3. This will be plus 2/3, so that's a total of 8/3. Downstairs, we've got a 9. And then if I do 8/3 times 1 over 9, multiplying by the reciprocal here, that's going to be 8 over 27 for our final simplified answer. For this problem, I'm given the points 1, 2 and 7/2, 1 on the curve, and the final boss battle task of this free response is to find y inverse prime of 1. Okay, so for this, let me again recall my dy over dx from part A. That was negative y over x plus y. That's going to be useful yet again. And let me also set this up in my inverse format for the derivative of an inverse. I can say y inverse prime of 1 equals 1 over y prime of y inverse of 1. So this is just, in general, we always have 1 over the derivative of the original with the inverse plugged in. So what is y inverse of 1? Well, that's the thing I have to plug into the y function to get back an output of 1. Looking at my 2 points here, the output of 1 is in this second point. And to get this output of 1, I had to plug in the input, the x value of 7/2. So down here, I've really got 1 over y prime of 7/2. And at this point, I need to figure out what the derivative of 7/2 is. For that, I'm going to have to use my derivative formula here. So let me evaluate dy over dx at x equals, or x comma y equals this point right here. So that's going to be negative y value, so negative 1 up top, over the x value 7/2 plus the y value 1. Now down here, this is 7/2 plus 2/2, so that's 9/2, negative 1 over 9/2. And same change flip, this becomes negative 2 over 9. Now be careful, this is not the final answer. This is just y prime of 7 halves. To get the final answer, we need to actually do 1 over this fraction. And same change flip again. A lot of flipping going on here. This is going to be negative 9 over 2.